Let me fill in a little terminology that you may encounter with respect to functional update and imperative update. I've been using imperative update and mutable data type interchangeably, and you'll see many APIs that provide mutable data types, especially hash tables or dictionaries, are often expressed in a mutable form. And Plait actually gives you hash tables in a mutable form. So we could define HT to be that hash table. They print out like this, hash A1, B2, for example. This is the hash table that maps the symbol A to the number 1 and the symbol B to 2. And I can use hash ref on HT to look up the value for A. It says sum of 1 and not just 1, because what if I ask for something that's not there? Then it says none. But the point is that we looked in the hash table and we got the value 1 out for A. And if I use hash set with an exclamation mark, I can change the value from A to 3. And now if I do hash ref HTA, then I get a 3 out. So that's the usual kind of hash tables or dictionaries that you would find in something like Python and JavaScript, where you can modify the mapping. In addition, though, Plait provides a functional update version of hash tables. And you might see this kind of thing described as a persistent data type. It's persistent because when we update the hash table with a new value, we still have the old hash table. And let me illustrate that over here. So let's get back our hash table, but instead of make hash, there's a different function called just hash that looks the same when we print out the table, but it's a functional hash table or a persistent version of hash table. So that when I do hash set without an exclamation mark, set A to be 3, then I get back a new hash table that has A to 3 and B to 2. Let's define that one to be ht2 to be hash set, no exclamation mark, of ht A to 3. If I do hash ref of ht2 on A, I see that it's mapped to 3, but I still have the same hash table before, ht, where A is still mapped to 1. So this is a persistent variant of hash tables. It's called persistent because the ht here, the old value, persists. I could use it for comparisons. I could use it if I need the old hash table, but I want something with an updated mapping. And the complexity on these operations are still what you want out of a dictionary or hash table. Setting something is still a constant time operation, and that means internally it has to be implemented a little differently. But it is possible to make persistent variants of your usual data types, and those are useful in many kinds of programs. Besides Plait, some languages that you can look at that have a lot of persistent data types are Clojure or Haskell.